We are looking at this problem min stack. Design a stack that supports push, pop, and top and retrieving the minimum element in constant time. Implement this min stack class we are given. The min stack, this would initialize the stack. It's basic initialization. We have this function push, which receives a value. And this we are supposed to push into the stack. Pop would very simply remove the element from top of the stack. Top would give us the element on top of the stack but not remove it. Very basic top operation on a stack. Get minimum would retrieve the minimum element in the stack. Very important to know. We are supposed to implement all these operations in O of one time complexity. Let's take this example. We have this stack over here. The first is a push operation for -2. So -2 is over here. Then we have a push operation for 0. So we input 0 over here. Then we have a push operation again for -3. So -3 is over here. Then we have get minimum, and that is giving us a minimum of, let's take a look at here, -3. We can see -3 is the minimum element here. So we get -3 in our response. Then we have a pop. We basically remove this top element. Now we do this top, which means we return 0. And that's what we are getting here. We are getting 0. And then we say get minimum again. Earlier it was -3, but since -3 is removed, the new get minimum is -2. We are getting -2 over here. If we were not given that we need to solve it in O of 1, this would be a very simple problem. We can either traverse this array, or we can use another stack to store these values for some time in this. But we are not supposed to do that because that would require O of n time. Now, since we are supposed to do this in O of 1, can we take this approach that every element knows what is the minimum before it? So 0 knows what is the minimum before it, -2. This -3 knows the minimum element. It can just compare with the minimum just before -3. For example, how about we store something like this? I take a stack. When I enter -2, -2 goes over here, and it also remembers the minimum at this position. It itself is the minimum, so it remembers that it itself is the minimum. Then we have 0, the next element. 0 is in the stack, and it also remembers what is the minimum, and that is comparing 0 with the minimum just before it, -2. This is the minimum we have, so we can say -2 is the minimum so far. Then -3 comes into the picture. Now -3 compares with this. It can compare that, okay, -3 is now the minimum. So in a situation where we remove this, we still know that the minimum is no longer -3, it's -2. So in this problem, the stack would not be a very simple stack. It would be a list. A list that contains first element as the stack value and the second as the minimum value. This would be the algorithm for get minimum. Top and pop should be very simple. These are just the top element of the stack. We can do it very easily. Push, we have to take care of the minimum element. So not just pushing the value, but also calculating the minimum. So -3 in this point. So we have to take care of that when we write this code. So this would be the basic idea. Let's take a look at the code implementation of this. Here in the code editor, I have this function minimum stack and a constructor in it these four functions: push, pop, top, and get minimum. Let's start with the constructor. Let's initialize a stack. So in Python, I can use a list. Now let's go to the push function. Every time I push a value, I also need to store the minimum of that stack so far. So let's first find out what is the minimum so far. Let's call it minimum. And the minimum so far I can get from the get minimum function. So I can call this function self dot get minimum. I get the minimum so far. Maybe the next value coming in is smaller. So if value is less than minimum, I would like to change the new minimum, right? The value is smaller than the minimum so far. So minimum equals to value. This would change. Otherwise, the minimum would stay the same, and this is what we would push in the stack, the same minimum as before. After that, let's push the value in this stack. So self dot stack dot append. I would like to append a list. The first would be the value itself, and the next would be the minimum. This would be the minimum. So now this should be it. We don't have to return anything from here. Let's go to the pop function. In pop, I'm just going to blindly remove on the top element, and we don't have to return anything from here. So self dot stack dot pop, I can do that with a list in Python. Now the top element, this is the top element. So self dot stack, the top element would be -1, right? But this would give me a list which I created for my convenience. It wants the value. So the value would be stored in 0. And this I am supposed to return this value from here. Get minimum. Now get minimum would be very simple. I can return the self dot stack, the top value -1, but I'm supposed to return the value, right? Which is stored at 1 index. This would give me the top value of the stack, and this would give me the minimum value. There is a possibility that stack is empty. We should handle that, right? So if the length of stack, if this is equals to 0, in that case we don't have a minimum. So how about we return just none? We return none, that okay, there is no minimum. Now we have to handle this in the push function too, because there is a possibility minimum is none. If minimum is none, value becomes the new minimum, which means I can just call here minimum if equals to none. I want to execute this and make minimum equals to value. So I can write it something like this. So either this is true or we get a none. None we will only get when value is the first element. Now this should be it. Let's try to run this code. I have a small typo here. Let's run it again. Let's submit it. We have a solution. If this video was helpful to you, please consider subscribing for more such content.